I think the original mandate, as I understood it for human biology, was to basically blend biology and social sciences with an emphasis on sort of policy issues. And it was originally intended to be a very small department, but it actually struck a chord with the undergraduates. So within a year or two, it was one of the largest majors on campus, and people were sort of flocking. First class I took in human biology was a class by Colin Pittendrick, which was Human Biology 1, and this was one of the most popular classes on campus. And we now have our teaching award dedicated to him, and he was absolutely a brilliant, inspiring professor. Teaching has always sort of found me. In fact, that's how I got into human biology. A few years later, I was actually at a wedding, and I mentioned to sitting next to the chairman of the department that it would be fun someday to come back and give a lecture in human biology. 2 weeks later, he called me up and asked me if I would teach a chemistry class for human biology. I think one thing that's fun about teaching is that you get to be immersed in the material. That's very exciting, but the thing that actually keeps me in teaching is the opportunity to work with the best and the brightest students, in the world at Stanford. And the fun thing about being here for a long time is I've not only gotten to work with them as undergraduates, they've gone on to do amazing things. One of my former students and TAs was in town recently with his family, and it turns out that he is involved in doing outbreak investigations in the Pacific Rim. He's based in Hawaii, and one of the outbreak investigations he had done when he was with the Epidemiological Intelligence Service in Atlanta was an outbreak investigation of measles. And it turns out he was going to be at Stanford on the same day that I was giving the measles lecture, and so I had him come in and talk to the medical students about this really kind of remarkable outbreak investigation that he had done that was recently published. For many years, starting in the 80s, I taught a class on HIV. It was actually inspired by a student who put on a conference in 1986. And so this class was actually started in 1988, and it was one of the first classes on HIV in the country. And what I did was I brought together people from all over the Bay Area who were pioneers in this field at Stanford, in Berkeley, and at UCSF. So it was a very exciting time. And the reason I say that that's sort of an iconic example of human biology is because it looked at all the both medical, biological, social, demographic issues involved in this epidemic, down to issues of behavior change and what the relationship between knowledge and behavior change is. I've been involved in a number of classes at Stanford that are 3-week intensive classes, and a couple of those were taught through the Bing Overseas Seminars program. And I took a group of students to Tanzania for 3 weeks to look at issues of development in northern Tanzania. The following year, we were very interested in doing a similar project in Kenya. And so we actually set up a class that was called the Kenya course, and basically we looked at issues of development in central Kenya, and we were located in Chogoria at the base of Mount Kenya. 7 undergraduates and 4 medical students were involved with this project that was linked to Village Hope Corps International, a microfinance organization that is somewhat unique in terms of targeting groups of individuals who are all HIV positive. And so the idea here is that in order to get their microfinance, they actually have to agree to take their antiretrovirals. The drugs are actually available for free through distribution through the PEPFAR program. And at least in the initial years that this was done, the groups that were previously unfunded because of the stigma of HIV were actually found to have the highest repayment rate, and because they were all on antiretrovirals, none of those individuals didn't pay their loan as a result of illness. many of these students are more changed even than their subjects, and their students are. They come back, and a huge percentage of these actually pursue careers and other activities that are involved in helping people and are involved in interceding in the HIV epidemic or in other important issues. One of my students, Johnny Dorsey, came back from a summer in Africa and started an organization called Face AIDS, in which he was going to try to raise $1 million to fund issues of HIV in Africa. He basically set up a remarkable organization that's spread across the entire country and has raised far more than their intended target of $1 million. It's interesting to me that now there's a great movement toward interdisciplinary study, and there's was a very successful project that was started a number of years ago called BioX, and it was to combine bio with any number of different fields: bioengineering, biochemistry, biophysics. And the way I think about it is that human biology was in some sense the original BioX. It was an interdisciplinary opportunity to combine biology with the social sciences. I think the founders of the department were very wise in sort of blending the issues of policy with the issues of biology or the issues of science, because I find far too frequently people want to make policy issues without actually understanding the underlying basis of the policy. And a lot of times there are examples where they make policies about HIV, but they're not consistent with the biology of HIV, where they make pronouncements about the fact that we're going to have a vaccine for HIV in 5 years, which is preposterous, since the average for easy vaccines tends to be about 15 years between the development of the vaccine and licensure of the vaccine. For a difficult vaccine like HIV, it's probably going to be longer. And so people who don't understand the biology kind of make pronouncements. The biology also helps us because people make pronouncements about, they say, well, HIV is a really difficult disease and so we can't make a vaccine for it. And we actually do have a vaccine for another sort of distant cousin of HIV called feline leukemia virus. And what that shows us is kind of the principal proof of concept that it is possible to vaccinate against a retrovirus. We just haven't figured it out for HIV yet, but it doesn't mean it's an unsolvable issue. I mean, I think predicting major breakthroughs in science, biology is very difficult to do, and people who've tried it in the past have been dramatically unsuccessful. I think it's possible to extrapolate some of the technologies we have now and see where they're going. I think that it's certainly clear that we haven't begun to exhaust the possibilities for the development of rational drugs based on using information that's come out of the human genome and out of protein structure. I don't think we've begun to exhaust the possibilities of vaccination against different types of cancer. This morning I actually gave a lecture on human papillomavirus to the medical students, and it's really quite a remarkable story because the vaccine that has come out, there's actually 2 vaccines, prevents infection with two strains for one virus and 4 strains for another virus, and this includes viruses that are associated with the development of cervical cancer. We're using either of the vaccines for human papillomavirus. We can actually prevent more than 5% of the world cancers, and that's just one example. Another vaccine, the vaccine for hepatitis B, which was actually developed by Brooke Blumberg, who used to teach in human biology, is also capable of preventing one of the world's leading cancers, namely primary hepatocellular carcinoma. Looking in the past, it's actually somewhat remarkable to me that many of the themes that first arose in human biology in the 70s are still pretty prominent. I think I'm more struck by the similarities in the students now, in the issues now. Some of the specific issues have changed. So the global warming was not really on the table, although there were people that were talking about depletion of resources and things like that in those days as well. There's a lot of interest in issues of global warming and climate change, and there's been a lot of creative people and creative ideas and money looking at that issue. I think that the problems of global warming are extremely real, but in some sense I think that it's a diversion from the real issue. I think the real issue is the issue of population, and I think until you deal with the issue of population, you're never going to make a dent in issues of climate change. Paul Ehrlich had done seminal work on this in the 60s and wrote a book that for me was very influential, The Population Bomb. I think a lot of that stuff is still relevant, so it wasn't that this is new right now in the era of global warming. This has been with us for a long time. I think it's really important for students to understand the role of synchrony in all of our lives. I actually taught a class called the Stanford Safari, and we interviewed lots of people at Stanford that were very important in the university, all the living presidents, most of the deans, Nobel Prize winners, and one theme became clear is that none of them are doing what they expected to do. You know, chance events have affected their lives to a great degree. I teach a lot about Darwin, so I use examples from Darwin about how chance events, serendipity, led to his being on the Beagle, and led to his discovery of his principles. And I look at my own life, and I think that some of the most important turning points in my life were just pure chance. In addition to serendipity, one of the things I've done is I've actually pursued a lot of different things and sent out inquiries. So what I often tell my students is they should apply for many fellowships because they may be very qualified, but there's a lot of qualified people out there, and so if you put a lot of bets on the table, you're much more likely to win a big hand.